Lagrange's mean value theorem. Statement: suppose that function f is defined on closed and bounded interval AB, and f of x is derivable on open interval AB, then there exists at least one point C in AB, open interval AB, such that f dash c is equal to f of b minus f of a divided by b minus a. So this is the statement of Lagrange's mean value theorem. Now to prove this, so what is the first of all, what is given here? So given f is close, suppose a function f is continuous on, here is one statement, continuous, okay, given f is continuous on closed interval AB, this is one thing is given. Second, f is derivable on open interval AB. Then our claim is, then we want to prove here, that is here our claim is there exists at least one point C in AB such that f dash c is equal to f of b minus f of a divided by b minus a. So we have given two, this is the given part, f is continuous and derivable, and we want to prove this f dash c is equal to. So now to prove this, first of all we assume here, now consider a function, or define a function on closed bounded interval AB such as phi of x is equal to f of x minus a of x, and here we here a is chosen such that, here we choose a is constant and we chosen such that phi of a is equal to phi of b. So we define here new function, phi of x is equal to f of x minus a of x, and here where a is constant, what is here a is what? A is constant, and we select here the value of a such that phi of a is equal to phi of b. Now this function phi of x, now since f of x is continuous, instead of that I am writing here, now phi of x is continuous on closed interval AB. Why? The reason is that the first is since f of x is continuous and x is continuous, So f of x minus a of x is also continuous. So what is f phi of x? This is what phi of x, but f of x is continuous. It is what given here is given. F is continuous, and we know that x is a continuous function. Okay, so a of x is also continuous. So f of x minus a of x is what continuous. This implies phi of x is continuous on AB. Next, since phi of x is also differentiable, phi of x is differentiable on AB. Now why it is differentiable? Again the same, since f is differentiable and x is also differentiable, so their difference is also differentiable. So it is given here, it is given f is derivable on AB. So f is derivable implies f is derivable, and we know the derivative of x is what? A. So this ax is also derivable. So this implies phi of x is also what? Differentiable, and phi of a is equal to phi of b. So these three conditions are the condition of Rolle's theorem. These are the condition of Rolle's theorem. So by using Rolle's theorem, there exists a C belongs to AB such that phi dash C is equal to 0. These are the three condition of Rolle's theorem. But what is phi of x? Since phi of x is equal to f of x minus a of x, so what is phi dash of x? So phi dash of x is equal to f dash x, and derivative of x is what? A. But what is phi dash c? Phi dash c is equal to 0. If we put here phi dash c, so phi dash c is equal to f dash c minus a, and therefore if phi dash c is equal to 0 implies f dash c minus a is equal to 0. But this implies f dash c is equal to what? A. Now say this is equation number star. Now we want to determine value of a. So to find value of a, we are going to use here this condition, condition number 3, phi of a equal to phi of b. Here we chosen a such that phi of a equal to b. What is the condition on a? We have chosen here a such that phi of a equal to phi of b. So by using this condition, we are going to determine value of a. So now since phi of a equal to phi of b, so this implies what is phi of x? This is the phi of x, f of x minus a of x. So this implies it is f of a minus a into a equal to f of b minus a into b. So if you simplify this is, as we can write this as ab minus aa. That is we write we consider, or we write this term, we convert this term into left hand side, and we write this term into what? A right hand side. So if we simplify this, it is equal to f of b minus f of a. So this is equal to, now if we take a outside, it is what? B minus a is equal to f of b minus f of a. So what this implies, a is equal to what? F of b minus f of a divided by b minus a. So this is what? The value of a. So if we substitute this value, so put a is equal to f of b minus f of a divided by b minus a in star. So this is the equation number star. Here you can check, this is equation number star. So if we put here, we get f dash c such that f dash c is equal to f of b minus f of a divided by b minus a. And what is here? C. What is hence the proof? But what is c here? C, by using, you can check here, what this c satisfy what here? By using Rolle's theorem, c is what? Lie in open interval ab, where you can write here where c lies in the open interval ab, and therefore here we have verified the Lagrange's mean value theorem, LMVT. Okay, so now what is the geometrical interpretation of this theorem? So geometrically you can write here, geometrically, going to change your color, say geometrically, you can write this as now if we consider this say instead of this, so again we consider here okay, and if we join this two end points, says this is the a f of a and b f of b. So this is what a f of a, this is a, and here f of a, and here say it is what b, and here f of b. Okay, so then if we join this point a f of a and b f of b by chord, then this there exists a tangent which is parallel to this chord. So here there exists this tangent. This is what a point C. So at this point at this point your tangent is parallel to the chord joining a f of a and b f of b, b f of b. So what is geometrical interpretation? Geometrically we can write, states that there exists at least one point. You can write here, there exists, say here, there exists at least one point C in AB such that the tangent is parallel, such that tangent is parallel. There is a point C on curve what is C C on the curve y, on the curve y, such that the tangent is parallel to the line segment through through the points a f of a, through the points a f of a and b f of b. So this is what geometrical interpretation. What is geometrically? There exists at least one point C on the curve y such that tangent is parallel to what? Line segment through the point a f of a and b f of b. So here is the point C. You can check here. This is the one point. This is one point. Here is one point, and it is parallel to what? The line joining the point a f of a and b f of b. Here is the line I am highlighting here. Here, this is the line. This is the line, and this is what? This is tangent line. What? Tangent line. Okay, these are the three tangent line, and this color, blue color is what? It is what? A line joining the point a f of a and b f of b.